You know, some of the most amazing science comes from the weirdest places. And today, we are diving deep into a topic that's, well, it's hilarious, but it's also serious physics. We're talking about penguins. And yeah, we're talking about their poop. Their explosive poop.
So, where does a story like this even begin? Well, believe it or not, it all kicked off with a simple, kind of funny mistake. A scientist, Victor Benomire Rocco, was talking about his trip to Antarctica. He's showing pictures, and a young woman in the audience points to these white and pink lines shooting out from a penguin nest. And she asks, how do the penguins make such pretty decorations?
Decorations? Can you imagine? Obviously, they weren't decorations. They were, well, poop streaks. But that one innocent question got the scientists thinking. Like, really thinking. Wait a minute, how do they do that? What kind of forces are we talking about here? And seriously, what on earth can penguin poop teach us about physics? Turns out, a lot. Okay, so before we get to the wild physics calculations, you gotta understand the why. It all comes down to a real problem a nesting penguin faces.
So here's the penguin's dilemma, right? You're sitting on your precious eggs. You absolutely cannot leave them, not even for a minute, because there are predators everywhere. But you also really gotta go. And you can't just, mess up your own nest. So what's the solution? Nature's solution is brilliant. You just turn around, point your rear end away from the nest, and fire! And here's the fun little bonus fact. The color of those streaks tells you what's on the menu. If it's white, they've been eating fish. If it's pink, it's krill.
Right, so this whole aim and fire thing was so wild that a couple of scientists back in 2003 were like, we have to figure out the math behind this. This wasn't just a joke anymore. No, this was a serious question of fluid dynamics that was just begging for an answer.
And their paper, when it came out in 2003, it made a huge splash. It even won something called an Ig Nobel Prize. These are awards for science that, first makes you laugh, then really makes you think. And this was the perfect example. But the story wasn't over. Not by a long shot. Fast forward almost 2 decades to 2020, and a whole new team of scientists said, you know what? We can do better. Let's revisit this.
So what did that first study even look at? Well, they focused on one key thing, rectal pressure. It's basically the power, the force the penguin generates inside its body to shoot the poop out. And they calculated it was somewhere between 10 and 60 kilopascals. Now, I know what you're thinking. What in the world is a kilopascal? Don't worry, let's break that down.
Okay, get this. That pressure is up to 3 times what a human can generate. For a bird that small, that is an insane amount of force. So that first study was already mind-blowing, but you know how science works, it's always about building on what came before.
So, like I said, fast forward more than 15 years. 2 Japanese scientists, Hiroyuki Tajima and Fumiya Fujisawa, looked at that original paper and thought, that's a good start, but it's too simple. They noticed that penguins don't just shoot straight out. No, it's more like a cannonball, flying in a big arc. It was definitely time for a physics update.
And this is where it gets really cool, seeing how the science evolved. The 2003 study, it basically assumed the poop flew in a straight, flat line. But the 2020 study went the whole 9 yards. They calculated the full arcing trajectory, just like you would for an artillery shell. They even added in things like air resistance and, get this, the viscosity of the poop itself. Yeah, they went there.
So with this new, way more advanced model, the 2020 team crunched the numbers again, and what they found was even crazier than what the first team discovered. The numbers are just, wow.
Okay, first, the maximum distance. They calculated it could fly 1.34 meters. That's over 4 feet! We're talking about a poop bomb traveling almost twice the penguin's own body length. And the speed? It leaves the penguin at almost 5 miles an hour. This isn't just plopping out. This is a launch. A high-speed launch.
And at all-important rectal pressure, their new, more precise calculation put the max at 28.2 kilopascals, so a much more specific and still incredibly powerful number.
Okay, so what does all that really mean? The researchers gave us the perfect, if slightly horrifying, comparison. If you scaled this up to a human, it would be like an adult pooping over 10 feet. I'm not kidding.
That is just an absolutely mind-boggling and, let's be honest, hilarious feat of biology.
But look, beyond the funny pictures in your head and these wild numbers, there's a real point to all this. This isn't just scientists having a laugh. This research actually helps us understand animal behavior, and, believe it or not, it has some really practical uses.
So why does it matter? Well, for the penguins, it's simple. This superpower keeps their home clean and their babies safe from predators that might be attracted by the smell. And for us humans, it's actually super helpful for zookeepers. If you know the blast radius, you can design enclosures and create a safety zone so you don't get hit while you're trying to work. It's workplace safety, penguin style.
It really just goes to show you, doesn't it? Sometimes the silliest sounding questions lead to the most incredible science. And it really makes you wonder. I mean, if penguins are packing this kind of physics just to use the bathroom, what other insane animal superpowers are out there, just hiding in plain sight waiting for someone to ask a curious question?